Hello students. So today I am doing class for class 12 science. The topic is the same topic, that is matrix. So in the last online class also we were doing the same topic, that is matrix, and we discussed about the theoretical part of matrix. So how can we define matrix and what are the types of matrices? We discussed that. So in this case also in the first class I left some definitions out there, that is I forgot to tell you about the scalar matrix. Okay, so let us discuss about the scalar matrix today. So what do you mean by scalar matrix? What is meant by scalar matrix? So you know about diagonal matrix. If a diagonal matrix is that square matrix in which the leading diagonal are all non-zeros but all of the elements are zero. That means diagonal matrix is like 1, 2, 3. That is this is the leading diagonal, right? So this 1, 2, 3 is the leading diagonal and all of the elements are zero out here, but the leading diagonal. But the elements in the leading diagonal are non-zeros, and if all the elements are zero, then that is known as diagonal matrix. This is known as what? This is known as what? Diagonal matrix. This is known as the diagonal matrix. But what type of matrix is known as scalar matrix? If the diagonal elements are all same. If the diagonal matrix have got the same quantities, if this diagonal matrix have got the same elements or same quantities, then that matrix is known as what? Scalar matrix. Okay? If in the diagonal matrix, if all the elements are same out here, then that matrix is known as what? Scalar matrix. That is, suppose B is equal to, suppose this is K 0 0 0 K 0 and 0 0 K. So in this case all the leading diagonals are same here. These are of the same quantities, K, K, K. Then this B is known as what? Scalar matrix. Then this is known as what? This is known as scalar matrix. Is that clear to all of you? Or you may write, suppose this is B1 matrix and B2 matrix is your, suppose this is K0 0 K. So here also this is the second order matrix and the leading diagonal here is KK. These are of same quantities, isn't it? So this B2 is also known as what? This is also known as what? Scalar matrix. If the diagonal elements are same, that means in a diagonal matrix, if all the diagonal elements are same or the elements in the leading diagonal are same, then that matrix is known as what? Scalar matrix. So these are all about your scalar matrix. So now we'll discuss about operations on matrices. Operations on matrices. Okay. So now number one is scalar multiplication of a matrix. Scalar multiplication of a matrix. Okay? Of a matrix. Scalar multiplication of a matrix. And number two, addition and subtraction of two matrices. And number three is your multiplication of two matrices. Multiplication of two matrices. Multiplication of two matrices. Okay. So now let us discuss about the first point, that is scalar multiplication of a matrix. Okay, that is number one. let us discuss about scalar multiplication of a matrix. Suppose if you have the matrix A is equal to this is A11, A12, A13. A11 means this is the element in the first column and in the first row, that is first row and first column. So first number will represent the row and the second number will represent the column. So A11 means this is the element in the first row and first column. A12 means element in the first row and in the second column. A13 element in the first row and the third column. It is A21, A22, A23, and this is your A31, A32 and A33. So what is by A32? What is meant by A32 here? This is the element in the third row and second column, right? That is your A32. Is it clear to all of you now? So now suppose there is a scalar quantity K, that is Ka, where K is a scalar, right? So this matrix A is multiplied by some scalars K. So which is equal to, also you have to multiply the matrix on the right hand side by K, that is A11, A12, A13. Okay? As the next one is, what is the second row? A21, A22, A23. And what is the third row here? It is A31, A32, A33. Your third bracket is closed. This third bracket and the first bracket are the notations of matrix. But in case of determinant, we usually represented it within a vertical line, right? So now, this is a matrix case, right? So in this case, this K is the scalar multiplication of the matrix. You have to multiply all the elements by K. But in case of determinant, only one of the rows or one of the columns should be multiplied by some constant K. Scalar means it is a constant, okay? So in case of determinant, while multiplying by K, you have to multiply either first row or second row or third row, or you have to multiply K by the first column or the second column or the third column. But in case of matrix, you have to multiply all the elements here by K. So that is, you have to multiply all the elements by K. That is Ka11, Ka12, Ka13, right? And this is Ka21, Ka22, Ka23. Next one is Ka31, Ka32, Ka33. So this K is known as the scalar multiplication of a matrix. Is that clear to all of you? So this is number one, scalar multiplication of a matrix. So let's do number two now. So number two is addition and subtraction of two matrices. The addition and subtraction of two matrices is possible if both the matrices have got the same order. The addition and subtraction of two matrices is possible if both these two matrices have got the same order. Like example, suppose A is equal to, if you have 1, 2, 3, 4, 5, 6, right? And B should be also the same order, that is -4, 5, -3, 0, -2 and 1. So both these matrices A and B have got the same order, that is this matrix A is of order 2 cross 3, this is of order 2 cross 3, this is also of order 2 cross 3. Is that clear? That is, A is the given matrix of order 2 cross 3 and B is the given matrix of order 2 cross 3. That means they have got the same order. That means you can add them. So therefore, what is A plus B is equal to, let us write down the matrix A again. It is 1, 2, 3, 4, 5, 6 plus, is that clear? Then what is the second matrix B? minus 4, 5, minus 3, 0, minus 2, and this is your 1. Okay. Now you can easily add these two matrices, isn't it? So let us add them. So therefore, A plus B is equal to, now the corresponding elements should be added. That means 1 plus into minus 4. What is 1 minus 4? Minus 3. That is first element of the first row are added. Then again second element plus second element. 2 plus 5, that is 7. Right? Then 3 minus 3 is 0. We are adding the two matrices of the same order. 4 plus 0, that is 4. 5 plus minus 2, that is 3. 6 plus 1, that is 7. That is your matrix A plus B. Is that clear? So this is the addition of two matrices. Okay. So let us discuss about the subtraction of two matrices. Okay. So similarly, in the subtraction of two matrices, the subtraction of two matrices is possible if both the matrices have the same order here also. Okay. So now in this case, suppose A is equal to, suppose this is 1, 2, 3, 4, 5, 6. Okay. And B is equal to, B should be of the same order of A. That is, A is of order 2 cross 3. So B should be also of the same order. Suppose it is 0, minus 1, minus 3, 2, 6, minus 5. Is that clear? So now, what is A minus B now? So A minus B is equal to, you can write it as A plus into minus 1 into B, isn't it? So A minus B means is equal to A plus within bracket minus 1, plus or minus is minus, 1 into B is B, right? So what is A out here? It is 1, 2, 3, this is 4, 5, 6, plus this is your minus 1, okay? Now what is B out here? It is 0, minus 1, minus 3, and it is 2, 6, minus 5. Is that clear? Now, you know that this is the matrix B and this minus 1 is a constant, that is the scalar multiplication. Minus 1 is the scalar multiplication of the matrix B. Okay? So now what will you write here? Is equal to, now first matrix remains same, 1, 2, 3, and it is 4, 5, 6. Then write down plus sign here. Now multiply all these elements of the second matrix by the scalar multiplication minus 1. You have to multiply all these elements of the second matrix by the scalar multiplication minus 1. Okay? So minus 1 into 0 is always 0. So minus into minus plus 1, minus into minus plus 3, minus 1 into 2, minus 2, minus 1 into 6, minus 6, minus 1 into minus 5, that is plus 5. So I already told you about the scalar multiplication of the matrix in the first case, isn't it? That is in number 1, scalar multiplication of a matrix. This minus 1 is the scalar multiplication of the matrix. So you have to multiply all the elements of the given matrix by the scalar multiplication, that is minus 1. Is that clear? So we got this expression. Now we can add those two matrices now, isn't it? So is equal to 1 plus 0, 1, 2 plus 1 is 3, 3 plus 3 is 6, right? 4 minus 2 is 2, 5 minus 6 is minus 1, 6 plus 5 is your 11. Is it clear to all of you? 1 plus 0 is 1, 2 plus 1 is 3, 3 plus 3 is 6, 4 minus 2 is 2, 5 minus 6 is minus 1, and 6 plus 5 is 11. So this is the matrix A minus B. Is that clear to all of you? So this is number 2 operation on matrices, that is addition and subtraction of two matrices. Okay. Now let us discuss about third one, that is multiplication of two matrices, right? So now multiplication of two matrices. Multiplication of two matrices, that is number 3. So you have to remember a condition for the multiplication of two matrices. There is a condition for the multiplication of two matrices. So what is the condition for multiplication of two matrices? Okay, suppose capital A is equal to 1 2 3 4, okay, and B is equal to 3 4 5 6 9 2, right? So now in this case, what is the order of the matrix A? 2 rows and 2 columns, that is 2 cross 2, right? So now what is the order of the matrix B? It is 2 rows 3 columns. It is 2 rows 3 columns. Is that clear now? So now, when is the multiplication of these two matrices possible? So here the order are not same. This A matrix is of order 2 cross 2, and this matrix B is of order 2 cross 3. But in this case the order are not same. But in this case, when is the multiplication of two matrices possible? So for this first matrix A, if you want to get the matrix AB, that is product AB, or multiply the matrix A by multiply matrix A by matrix B. If you want to get the product AB, or if you want to get the matrix AB, so first of all in matrix A you have to consider the number of columns. So what is the number of columns here? It is 2. And for matrix B, for the second matrix B, because we are getting matrix AB, for matrix A you have to consider the number of columns. What is the number of columns here? 2. And for the second matrix B, you have to consider the number of rows. How many rows are there? 2 rows. So these two must be equal. So matrix multiplication AB is possible if number of columns of A is equal to number of rows of B. Then only the matrix multiplication is possible here. Because while multiplying matrix A by matrix B, you have to multiply row by column. That's why for the first matrix A, for the first matrix A, you should consider the number of columns, and for the second matrix B, you should consider the number of rows. So here for matrix A, number of columns 2, and for matrix B, number of rows is 2. So they are equal. That means you can multiply A by B. That is, matrix multiplication AB is possible. Okay. So in this case, AB is possible. So how is it possible? Because number of columns of A, COLUMNS, number of columns of A is equal to number of rows of B. Because AB is possible, matrix multiplication AB is possible if number of columns of A is equal to number of rows of B. Okay. So now, is BA possible? Can you find out the matrix B into A? Can you find out the matrix BA? Now first, B is written out here. Matrix B is written out here. You have to consider the columns of B now. What is the columns of B? It is 3. Okay. What is the columns of B? It is 3. And you have to consider the rows of the matrix A, because A is written in the second one. Okay. So what is the number of rows of A? It is 2. Are they equal? They are not equal. That means the matrix multiplication BA is not possible. That is, the matrix multiplication, BA is not possible. Is not possible. Is that clear to all of you? The matrix multiplication AB is possible if number of columns of the matrix A is equal to number of rows of matrix B. Is it clear now? So this is the multiplication of two matrices. Okay. So let us find out the matrix AB now. So in determinant also we did the multiplication of determinant. So in case of matrices also you can multiply the two matrices as we have done in determinant. Okay, so this matrix multiplication AB is possible. How is it possible? Because the number of columns of A is equal to number of rows of B. तो मैले अघि नै भनिहाले यदि तिमीलाई AB matrix multiply गर्नु छ भने त फर्स्टमा हामी के लेख्दै छौं? A को चाहिँ के हेर्नु पर्छ? नम्बर अफ कलम्स. यो नम्बर अफ कलम्स कति भयो? 2. अनि सेकेन्ड म्याट्रिक्स B को चाहिँ के हेर्नु पर्छ? नम्बर अफ रोज हेर्नु पर्छ. त नम्बर अफ रोज कति भयो यहाँ? 2 भयो. That means number of columns of A is equal to number of rows of B. That is matrix multiplication AB is possible. Is it clear now? So you can find out AB matrix. So let us find it. Okay. So let us find out AB matrix. So this is your 2 cross 2 matrix. This is your 2 cross 3 matrix. Right. So let us find out the matrix AB. So now always in this case you have to multiply row by column. This first row by first column. You have to multiply the corresponding elements. First element into first element. 1 into 3 is 3. Then write down plus 2 6 that is 12. Is that clear? That is first row by first column. So corresponding elements should be multiplied. 1 3 3 plus 2 6 12. Is that clear? Next one. What will be the second element of the first row? Again, this first row is multiplied by the second column. Okay, this first row is multiplied by the second column, and you should write it in the second element of the first row. That is 1 4 4 plus 2 9 18. That is corresponding elements are multiplied. That is 1 into 4 is 4 plus 2 into 9 is 18. Again. This first row is multiplied by the third column. This first row is multiplied by the third column. But the corresponding elements should be multiplied. That is 1 5 5 plus this 2 2 4. Is it clear now? Now we have finished this first row. First row ko kaam complete bhayo. Is that clear? Now for the second row. Now in this case, now this second row should be multiplied by the first column, but the corresponding elements should be multiplied. So 3 3 9 plus this 4 6 24. Is that clear? Now again, this second row should be multiplied by this second column, but the corresponding elements should be multiplied. That is 3 4 12 plus 4 9 36. Is that clear? Next, again, what will be the third element of the second row? Again, this second row should be multiplied by this third column. So corresponding elements should be multiplied. 3 5 15 plus 4 2 8. So this is your matrix multiplication. I think you have understood it. So what will be the order of this matrix AB? So these two remain same. So the order of this matrix AB should be 2 cross 3. It should be 2 cross 3. Is it 2 cross 3? Yes. This is 2 rows and how many columns? 3 columns. Right? So therefore AB is equal to what? So AB is equal to, what can you write? 3 plus 12 is 15. 4 plus 18. 3 plus 12 is 15. 4 plus 18, 22. 5 plus 4, 9. 9 plus 24. This is your 33, isn't it? And 12 plus 36, 48. And 15 plus 8, that is 23. So this is the matrix multiplication AB. Is it clear now? So now you can write a property out here. The matrix multiplication, AB is possible if now the first matrix here is A. You have to consider the number of columns of A, right? The matrix multiplication AB is possible if number of columns of A number of columns of A or matrix A is equal to number of rows of matrix B. So is that clear to all of you? So this is the third case, that is multiplication of the two matrices. The matrix multiplication AB is possible of the two matrices A and B if number of columns of matrix A is equal to number of rows of matrix B. Suppose if you write BA, so in this case B is written first and then A. The first को B को हामीले के हेर्नुपर्छ, number of columns हेर्नुपर्छ. So you should consider the number of columns of B and you should consider the number of rows of A. That is, matrix multiplication BA is possible if the number of columns of the matrix B is equal to number of rows of the matrix A. Is that clear to all of you? So now we'll do some problems. Okay, so these are all the theoretical part. You should know it. So try to understand it. Now we'll do the next problem part. Okay. So now we will do some problems from the book Higher Mathematics for class 12 by Sailendra. Okay, that is exercise 1, page number 133, and here also each question carries 2 marks. Let's do question number 1. So here the matrix A is given. A is equal to 2 minus 3 0 1 minus 1 4. This is 3 cross 2 matrix, isn't it? 3 rows 2 columns. B is equal to minus 1 5 2 minus 3 0 1. This is also 3 cross 2 matrix. And C is equal to 4 minus 2 0 minus 1 3 5. You know rows and columns, isn't it? So this is also of order 3 cross 2. So now we have to find out the matrices. That is number 1 A plus 2B, number 2 2B minus 3C, number 3 4C minus A, and number 4 A plus 4B minus 3C. So let us do number 4. So you can do number 1 2 3 at home. This is your homework, right? So this is your homework. Number 2 is also your homework, and number 3 also, right? So let us do number 4 now. Now it is given A plus 4B then minus 3C. So is equal to, what is the matrix A out here? It is 2 minus 3 0 1 minus 1 4. Then plus 4. What is the matrix B? Let us write down the matrix B. Minus 1 5 2 minus 3 and 0 1. Then write down minus 3 into, what is C here, matrix? What is the matrix C here? 4 minus 2. It is 4 minus 2. Then next 0 minus 1 and 3 5. So this is the given matrix. Okay. So you have to find out A plus 4B minus 3C. Okay. So next, which is equal to, let us keep the first term as it is, that is 2 minus 3, 0 1, and this is minus 1 4, right? So let us write here plus sign. And so now this 4 is the scalar multiplication of the second matrix B, right? So you have to multiply all these elements by 4. You know scalar multiplication of matrix. We did it just now, isn't it? So let us multiply all these elements by 4. So what do we get? So it is minus 4, 4 into minus 1 minus 4, 4 into 5, 20, 4 into 2, that is 8, 4 into minus 3, that is minus 12, right? 4 zeros are 0, and this is 4 ones are 4. Then again plus. Now multiply by minus 3 there. What is minus 3 into 4? Minus 12, minus to minus plus 6, minus 3 into 0, 0, minus to minus plus 3 ones are 3, right? Minus 3 into 3, minus 9, minus 3 into 5, that is minus 15. So this is the third matrix out here. So is that clear to all of you? So we have multiplied by minus sign also here. Minus 12, minus into minus plus 6. This is 0, minus into minus plus 3. This is minus 9 and this is minus 15. Okay. So you can add these matrices. You can add those matrices because they have got the same order, right? So let us add the first two matrices first. Okay. 2 minus 4, minus 2, minus 3 plus 20, that is 17, and 0 plus 8, 8, 1 minus 12, minus 11, minus 1 plus 0, minus 1, 4 plus 4 is 8. Okay, plus. Now write down the third matrix now, that is minus 12, 6, 0, 3, minus 9, minus 15. Okay. So again you can add those two matrices here also. Let us add those two matrices. So we can add those two matrices because they have got the same order. This is 3 cross 2 matrix. This is also 3 cross 2 matrix. That means you can add them. So minus 2 minus 12 minus 14, 17 plus 6, 23, 8 plus 0, 8, minus 11 plus 3, minus 8, right? Minus 1, minus 9, same sign, add them, minus 10. And 8 minus 15 is minus 7. So these are the answers. So this is question number 1-4. So you can do the homework 1 number 1, 1 number 2 and 1 number 3 as homework. Okay. So let us do the next question now. So now we are doing question number 2 number 1. Each question carries 2 marks from the same page number 133. So before I do this number, let us discuss about the difference between the determinant and the matrix. Okay. So in case of determinant, this is determinant and this is your matrix. Okay. So determinant is represented by these vertical lines. You know that, isn't it? We have done determinant. So matrix is given by this, represented by third bracket or this first bracket. Okay. So determinant, in case of determinant, number of rows is equal to number of columns always in case of determinant, right? But in case of matrix, number of rows may or may not be equal to number of columns. In case of matrices, number of rows may or may not be equal to the number of columns. That means number of rows may be equal to number of columns or number of rows may not be equal to number of columns in case of matrix. Alright. So in case of determinant, if there is a constant before determinant, that one of the rows or one of the columns should be multiplied by that constant or that scalar multiplication. So if there is a scalar multiplication of a determinant, that one of the rows or one of the columns should be multiplied by that scalar constant. Okay. But in case of matrix, if you have got a scalar multiplication, suppose K is a scalar multiplication of that matrix, okay, of the given matrix, that matrix, all the elements of the matrix should be multiplied by that scalar. But in case of determinant, all the elements cannot be multiplied by that scalar multiplication. Okay. So in case of determinant, only one row or one column should be multiplied by that constant. But in case of matrix, all the elements of the matrix should be multiplied by that constant or that scalar. Is that clear to all of you? So these are the difference between determinant and matrix. Okay. So now let's do this problem now. So what is the problem out here? If capital A is equal to 2, 4, 5, 6, first row, second row, this is first column and this is your second column. This is 2 cross 2 matrix. If it is of order 2 cross 2, right? So matrix B is 3, 6, first row, 5, 9, second row. So this is also 2 cross 2 matrix. You have to find out the matrix X of order 2 cross 2 again, such that, what is the condition given here? 3A plus 4B is equal to 2X. So write down given here. Here given is, what is given here? It is 3A plus 4B is equal to twice X. Right? Or 3 into, what is the matrix A out here? it is 2, 4, 5, 6, right? Plus 4, what is the matrix B here? It is 3, 6, 5, 9, which is equal to twice x. Is that clear? So now, what is this 3? 3 is the scalar multiplication of this matrix. So you should multiply all the elements by 3, right? So it is 3 2s are 6, 3 4s are 12, 3 5s are 15, and 3 6s are, this is your 18 plus. Again, this 4 is the multiplication of this matrix. That is 4 3s are 12, 4 6s are 24, 4 5s are 20, and 4 9s are, this is 36, which is equal to twice x. Is it clear to all of you? So now, you know addition of two matrices. You can add these two matrices because they have got the same order, okay? So, or now let us add these two matrices on the left hand side, okay? So, corresponding elements should be added. What is 6 plus 12? 18. And 6 plus 12 is 18, you know that, isn't it? 12 plus 24 is, this is your 36. Next, 15 plus 20 is 35. 35, is that clear? And 18 plus 36 is 54. So it is 54. 8 plus 6 is 14, 4, 1. 4 plus 1 is 5. That is 54. Is equal to twice x. Is equal to twice x. Is it clear now? Now we have to get the value for x. Let us take these two to the left hand side. It is just like solving an equation. When these two goes to the left hand side, it goes to the denominator. That means you should write here half. So what is the matrix here? 18, 36, this is 35, and this is 54, which is equal to twice x. Is that clear to all of you? Now on the left hand side, this half is the scalar multiplication of the matrix. So you should multiply all the elements by this scalar, that is half. So what is, this is x only, because 2 is taken to the left hand side, isn't it? This 2 is taken to the left hand side, it becomes half. So this is only x. So what is x is equal to? So x is equal to multiply all the elements by half here. So half into 18, that is 9. Half into 36 is 18. And half into 35 is 35 by 2. And 2 in half into 54, that is your 2 2s are 4, 2 7s are 14. So this is the final answer. So what is the matrix x out here? It is in the first row 9 and 18, and in the second row 35 by 2 and 27. That is, all the elements are multiplied by the scalar multiplication, that is half. Okay, so I think I've understood it. So let's do the next problem now. So now we will do the next question, that is question number 2. Find a matrix X such that 2A plus B plus X is equal to O. It may be 0. O means null matrix, right? Or it may be 0. So 0 means if all the elements of a matrix are 0, then that is known as null matrix or 0 matrix, okay? And usually null matrix is denoted by O, right? Where A is equal to, this is the second order matrix, first row -1 2, second row 3 4, and B is equal to 3 minus 2, first row, second row 1 5. Okay, so you have to find out the matrix X, right? So here given is, so write on the given part. What is the given part here? 2A plus B plus X is equal to O, right? Or 2 into, what is the matrix A here? -1 2 3 4. Plus, what is the matrix B here? It is 3 minus 2 1 5, and plus X we don't know. So what is O here? So here O is the null matrix. So it is of order 2, that is all elements are what? It is 0 out here. Is that clear? So now in this case 2 is the scalar multiplication of this matrix. So you have to multiply all the elements of the matrix by this scalar multiplication 2. So 2 into -1, -2, 2 2s are 4, 2 3s are 6, 2 4s are 8, right? Then plus, this is your 3 minus 2, 1 5, plus X is equal to, this is the normal matrix, that is 0, 0, 0, 0. Alright? So let us simplify it now. Now we can simplify it further. Okay? So now you can add those two matrices here. Minus 2 plus 3. So they have the same order. So you can multiply the, and you can add those two matrices. So you have to add the corresponding elements of the two matrices. Minus 2 plus 3. That is 1. 4 minus 2. That is 2. 6 plus 1. 7. 8 plus 5. That is 13. Plus x, which is equal to, this is 0, 0, 0, 0, right? So this is just an equation. So you have to take that matrix which is on the left hand side to the right hand side. Okay? So let us take this matrix to the right hand side. It is just like solving an equation, isn't it? So x is equal to, so this is 0, 0, 0, 0. This is the normal matrix minus, then what do we write? So it is 1, 2, 7, 13, right? So minus means this is minus 1. This minus 1 is the scalar multiplication of this matrix, second matrix, isn't it? So x is equal to, this is 0, 0, 0, 0. Then this is plus, make it plus. Now minus 1 is the scalar multiplication of that matrix. So you multiply all the elements by this scalar multiplication minus 1. That is minus 1, minus 2, minus 7, and this is minus 13. Okay? So let us add them. This is the addition of the two matrices. We can add them 0, minus 1, minus 1, 0, minus 2, minus 2, 0, minus 7, minus 7, and 0, minus 13. That is minus 13. Okay? So this is the final answer. So I think I've understood it. You can do it at home. Okay? So you can copy it now. So we'll do the next question now. So now we'll do the next question, that is number 3. And I'll give you number 1 and 2 of number 3 as homework. Okay? So these all these 3 are similar type of questions. Okay? So let's do number 3 of number 3. That is, find the matrices A and B for which the number 3 is what? 2A plus B is equal to, the matrix is given here in the first row. So in the first row, 1, 2, 3. Second row, minus 1, minus 2, minus 3. And what is the third row here? 4, 2 and 3. And what is A plus 2B is equal to? In the first row, there are 3 elements, 0, 2, 3. Second row, 4, 1, 7. And the third row is, it is 1, 1, 5. So it is just like your simultaneous equation. You know how to solve a simultaneous equation, isn't it? Two equations with two unknown quantities x and y are given, so that you can easily solve that two equations to get the values of x and y. So here also A and B are the two matrices which are unknown matrix. So in the similar manner you can solve these two equations, right? So what is the first equation out here? It is given 2A plus B is equal to, what is it? 1, 2, 3, minus 1, minus 2, minus 3, and it is 4, 2, 3. This is the first given equation. Let us mark it as equation number 1, right? As the next one is, what is the second equation given here? It is A plus, it is 2B. A plus 2B is equal to what? A plus 2B is equal to, it is 0, 2, 3, 0, 2, 3. What is the second row? 4, 1, 7. It is 4, 1, 7. Then 1, 1, 5. 1, 1, 5. So this is your second equation. This is just like your simultaneous equation. So in this case, instead of x and y, the matrices A and B are given respectively. Okay. So now let us solve it. So either you can make the coefficient of A equal, or you can make the coefficient of B equal. So let us make this coefficient of B equal out here. Okay. So this one should be multiplied by what? 2. Because 2 into B is 2B. This is also 2B. But you have to multiply this equation 2 by 1 only, so that we can have the coefficients of b equal out here. Okay, so let us write it in the next step. Or, so what do we get? 2 2s are 4a plus 2b is equal to, now this matrix is the scalar multiplication of this 2. That is scalar multiplication, it is 2. 2 is the scalar multiplication of this matrix. Okay, so you have to multiply all these elements by 2 here. So multiply by 2 here, all the elements you multiply by 2. What do we get? 2 1s are 2, 2 2s are 4, 2 3s are 6, right? Similarly here, minus 2, minus 4, minus 2, minus 4, minus 6. Understood? 2 into minus 1, minus 2, 2 into minus 2, minus 4, 2 into minus 2, minus 6. Again, 2 4s are 8, 2 2s are 4, next 2 3s are 6. Okay, so this is your 4a plus 2b. As the next, second equation, keep it as it is. Okay, so it is multiplied by 1, so it remains same. That is a plus 2b. A plus 2b is equal to, what is the matrix given out here? Write on the matrix here. 0 2 3, right? 4 1 7, 4 1 7. Next 1 1 5, 1 1 5, right? So now, so what I'm going to do here? You can subtract it to cancel 2b, isn't it? Here the coefficient of b are same, so you can subtract it. Minus minus. Before this matrix there is also minus sign. You have to change the sign, right? You know how to subtract, isn't it? So while subtracting, you have to change the sign for the second equation, right? So write down next. Or now what is 4a minus a, that is 3a, is equal to 4a minus a is 3a, and here this 2b minus 2b gets cancelled, so you don't have to write it. So is equal to, now you have to do the subtraction of these two matrices. You can subtract them because they are of same order. Okay, what is 2? You have to subtract the corresponding elements. 2 minus 0, that is 2, right? Is that clear? Next, 4 minus 2, 2, 6 minus 3, 3. That is 2 2 3 in the first row. Next one is corresponding elements should be subtracted. Minus 2, minus 4, minus 6, minus 4, minus 1, minus 5, minus 4, minus 5, minus 1, minus 5, isn't it? This is minus 4, minus 1, minus 5, minus 6, minus 7, minus 13. Minus 13, is that right? Minus 6, minus 7, minus 13. 8 minus 1, 7. Next, 8 minus 1 is your 7, isn't it? So 8 minus 1 is 7. Next, 4 minus 1 is 3. And next, 6 minus 5 is 1. So this 6 minus 5 is 1. So let us put the value for, let us get the value for a. So what is a is equal to now? What is a is equal to? It is 1/3. Then 2, 2, 3, minus 6, minus 5, minus 13. Then this is 7, 3, 1. Is it clear to all of you now? As the next, or a is equal to, what is matrix A? Now you have to multiply all the elements by the scalar multiplication 1/3. So this 1/3 is the scalar multiplication of this matrix. So you have to multiply all these elements by 1/3. So what do we get? It is 2 by 3. This is also 2 by 3. 1 by 3 into 3 is 1, right? 1 by 3 into minus 6, minus 2, minus 5 by 3. And this is minus 13 by 3. Is that clear? Now what is the third row? It is 7 by 3. This is 7 by 3. This is 1. And this is 1/3. So this is the answer for the matrix A. So we got the matrix A. So now we have to get the matrix B. Again, let us take the two given matrix again. So what is the two given matrix out here again? Let us take it. So let us write down the two matrix again. That is 2a plus b is equal to, what is 2a plus b is equal to? It is 1, 2, 3. It is 1, 2, 3, minus 1, minus 2, minus 3, isn't it? And then 4, 2, 3. 4, 2, 3. Then it is 4, 2, 3. Right? So this was equation number 1. Right? And what was the second equation? Let us write the second equation again. What is the second equation here? It is a plus 2b is equal to, what is a plus 2b is equal to? It is 0, 2, 3, 0, 2, 3, next 4, 1, 7, it is 4, 1, 7, and the next one is 1, 1, 5. This is 1, 1, 5, right? So now let us mark it as number 2 again. Now in the previous step we made the coefficients of B equal and we cancel it and we get the matrix A. Now in this case, let us make the coefficient of A equal to cancel the matrix A so that you can get the matrix B. Okay? So 1 should be multiplied by 1 now, and this 2 should be multiplied by number 2. Okay? So let us simplify it now. So or this equation 1 remains same because it is multiplied by 1. That is 2a plus b is equal to, what is it? 1, 2, 3, minus 1, minus 2, minus 3, and it is 4, 2, 3. 4, 2, 3. Is that clear? Now equation 2. Write down equation 2 below this equation, but you have to multiply it by 2. You have to multiply all the terms by 2 out here. 2a plus 4b is equal to. So what is here? 2 zeros are 0, right? 2 twos are 4, 2 threes are 6, right? 2 fours are 8, 2 ones are 2, 2 sevens are 14, right? 2 fours are 8, 2 ones are 2, 2 sevens are 14, then 2 ones are 2, 2 ones are 2, 2 fives are 10, right? So let us simplify it. Is that okay? Let us check it. 2 into 8, 2a, 2 twos are 4b is equal to 2 zeros are 0, 2 twos are 4, 2 threes are 6. 2 fours are 8, 2 ones are 2, 2 sevens are 14, 2 ones are 2, 2 ones are 2, 2 fives are 10, right? So now let us subtract it because you have to cancel this 2a, that means you have to subtract these matrices from these matrices. So you have to change the sign in the second equation, right? So now, so it is therefore 2a minus 2a gets cancels, b minus 4b, that is minus 3b is equal to, now we have to subtract these two matrices, okay, 1 minus 0, that is 1, 2 minus 4, minus 2, 3 minus 6, minus 3, right, minus 1 minus 8, minus 9, minus 2 minus 2, minus 2 minus 2, minus 4, then minus 3 minus 14, minus 17, then 4 minus 2, 2, then 2 minus 2, 0 always, right, 2 minus 2, and this 3 minus 10 is minus 7. So this is the matrix on the right hand side. So we have subtracted this matrix from that matrices, isn't it? So now let us check it once again. 1 minus 0, 1, 2 minus 4, minus 2, 3 minus 6, minus 3, minus 1 minus 8, minus 9, minus 2 minus 2, minus 4, minus 3 minus 14, minus 17, then 4 minus 2 is 2, 2 minus 2 is 0, 3 minus 10 is minus 7, okay? So what is the value? B now, B is equal to, now you should take minus 3 to the right hand side. So on the right hand side you should write it in the denominator, that is minus 1/3, okay? And write on the matrix 1 minus 2 minus 3, minus 9 minus 4 minus 17, and this is 2, 0, minus 7. Is that clear to all of you? So next, so what is the answer for B? So now write down what is B is equal to now. What is the final answer for B, or what is the matrix B now? So you have, this is the scalar multiplication of this matrix. That is minus 1/3 is the scalar multiplication of this matrix. So now multiply all the elements by minus 1/3. So what do we get? It is minus 1/3, minus to minus plus 2/3, right? Minus to minus plus 1. Now multiply all the elements in the second row by minus 1/3. So what do we get? 3, 4 by 3, minus 2 minus plus 4 by 3, then plus 17 by 3, right? Then again minus 2/3, this is minus 2/3, this is 0, 0 in number order 0, then plus 7 by 3, plus 7 by 3. So these are the answers. So this is your matrix A and that is your matrix B. So these are the answers. So this is the method to do this problem. So similarly you can do 3, number 1 and number 2. That is your homework. Okay. So we'll do the next question now. Now we will do the next question, that is for number 1. If A is equal to, this is second order matrix 3, 5, 2A and B is equal to 4, B, 2, 9 and C is equal to 26, A, 14 and 45, right? So these are all second order matrices. You have to find out small a and small b when twice capital A plus 5 capital B is equal to C. Usually matrix is denoted by capital letter and the members of the elements of the matrix are denoted by small letters or numbers, right? So here it is given. Let us write down the given part. This is the solution. What is the given here? 2A plus 5B is equal to C. Or 2 into what is capital A? 3, 5, 2A plus 5 within bracket. What is the matrix B? 4B, 2, 9 is equal to what is the matrix C here? It is 26A. And this is 14, 45. Right? So, or here you should multiply by 2, 2 3s are 6, 2 5s are 10, 2 2s are 4, this is twice A, right? Plus, again here you should multiply by 5, 5 4s are 20, this is 5B, this is the scalar multiplication of the matrix, that is 5 is the scalar multiplication of the matrix, 4B 2 9, right? 5 2s are 10 and 9 5s are 45, which is equal to, now it is 26A 14 45. 26A 14 45. Is that clear now? So, or you can add those two matrices on the left hand side because they are of same order, right? 6 plus 26, 6 plus 20. 6 plus 20 is 26, then 10 plus 5B, right? Then 10 plus 5B, then 4 plus 10 is 14, and then 4 plus 10 is 14, and then 2A plus 45. It is 2A plus 45, which is equal to on the right hand side. So on the right hand side, what do we have here? On the right hand side, we have, so what is there on the right hand side? It is 26A, it is 26A, then 14 45. 14 45, right? So now you have to solve it. So you know from equality of two matrices, so when do the two matrices A and B equal? When are the two matrices equal? The two matrices are equal if they are of same order and their corresponding elements are also equal. The two matrices A and B are said to be equal if they are of same order and their corresponding elements or members are also same. So, or now this is 26 is equal to 26 is right, 14 is equal to 14 is also right. Now you can equate 2A plus 45 with 45. That is 2A plus 45 is equal to 45. Here 45 gets cancels. That is 2A is equal to, that is 0. That is, what is the value for A? A is equal to 0 by 2 is always 0. So we get A is equal to 0 here. Again, these two elements must be equal. That is, second element in the first row. In both the sides must be equal. Second element in the first row on both the sides must be equal from the definition of equality of two matrices, right? So again 10 plus 5B, 10 plus 5B is equal to A. So here A is 0, right? You can put the value for A in this case. So it is 10 plus 5b is equal to 0. Is that clear to all of you? Or in the next step, you can write 5b is equal to minus 10. Or what is the value of b? b is equal to what? It is minus 2. Is that clear? So what are the answers here now? A is equal to 0 and b is equal to minus 2. So these are the answers. A is equal to 0 and b is equal to what? It is minus 2. That is your answer. So you can copy it. We'll do the next question now. Assalam. We'll do the next question, that is for number 2. If a matrix has 18 elements, what are the possible orders it can have? If a matrix has 18 elements, so what are the possible orders that it can have? Okay. And now what if it has 5 elements? Suppose the matrix has only 5 elements. What type of order it can have? So you have to find it. Okay. So if a matrix has 18 elements, the possible orders it can have is equal to, so what are the possible orders that it can have? It may be 1 into 18, isn't it? There are 18 elements. 1 into 18 means, what do you mean by 1 into 18? 1 row and, that means 1 row and 18 columns. It may be, you can write it in the reverse way also, 18 into 1, right? So these are the two possible orders that it can have. So other one is 2 into 9, 2 9s are 18, isn't it? 2 into 9 or 9 into 2. That is 2 into 9 means 2 rows and 9 columns. 9 into 2 means 9 rows and 2 columns, right? As the next one is what? 3 6 are 18 or 6 cross 3. So is there any other possible orders other than this? No. Okay? 6 3s are 18, 2 9s are 18, 9 2s are 18, that is also written, and 18 1s are 18, 18 1s are 18. Okay? So the possible orders are 1 into 18, 1 row and 18 columns, 18 into 1, that is 18 rows and 1 column. Okay? 2 into 9, 2 rows and 9 columns, 9 into 2, 9 rows and 2 columns, 3 into 6, 3 rows and 6 columns, and 6 into 3, that is 6 rows and 3 columns. So these are the possible orders that the matrix can have, right? So if a matrix has 5 elements, what can we say about the orders? If a matrix has how many elements? 5 elements. Then the possible orders it can have is equal to, what is it? It is 1 into 5. That is 1 row and 5 columns and 5 cross 1. That means 5 rows and 1 column. So these are the possible orders that it can have when the matrix has 5 elements. Is that clear to all of you? So this is your answer. So we'll do the next question now. Now we are doing the next question, that is for number 3. Find the values of x and y if 2 into the matrix, second order matrix 1 3 0 x plus, there is another matrix, second order matrix, that is y 0 1 2 is equal to the right hand side matrix is there, that is 5 6 1 8. So this is the given equation. You have to get the values of x and y. So let us do the solution now. So here given is, what is given here? 2, this is 1 3 0 x then plus this is your y0 1 2, which is equal to, on the right hand side it is given 5 6 1 8. So let us simplify this given equation. Okay, so now here 2 is the scalar multiplication of this matrix, so you have to multiply all these elements of the matrix by 2. 2 1s are 2, 2 3s are 6, 2 0s are 0, 2 into x is 2x, right? Plus this is y0 1 2, this matrix remains same, is equal to, this is 5 6 1 8, right? So on the left hand side you can add those two matrices because they have the same order. So you can add those corresponding elements, that is 2 plus y, 2 plus y, 6 plus 0, 6, 0 plus 1, 1, this is 2x plus 2, 2x plus 2 is equal to, now it is 5 6 1 8. It is 5 6 1 8. Is it clear to all of you? Now these two matrices are equal. So from the definition of the equality of matrices, both the matrices should have the same order and the corresponding elements must be equal. So both the matrices have the same order, so it's correct. So corresponding elements must be equal. That is, first is equal to first element, second is equal to second element. In the second row also, first element is equal to first element and second element is equal to second element. Now this is 6 6 1 1. That's correct. Okay. 2 plus y is equal to 5. So you can equate 2 plus y is equal to 5. Or what is the value for y? Y is equal to, that is 5 minus 2, which is equal to 3. So again you can equate this 2x plus 2 with 8. That is 2x plus 2 is equal to 8. Alright. So or 2x is equal to 8 minus 2. What is 8 minus 2? That is 6. So or 2x is equal to 6. Or x is equal to, what is 6 by 2? That is 3. Okay. So what are the answers here? What are the values of x and y? You are asked to find out the values of x and y. So x is equal to 3 and y is equal to 3. So x is equal to 3, y is equal to 3. So this is the answer. Is it clear now? So you can copy it. So we'll do the next question. So now we'll do the next question, that is point number 4. You have to find out the values of x, y and z if these two matrices are equal. And you know that on the left hand side a matrix is given. That matrix is known as the column matrix because only one column is there. This is three rows and one column. So this is only one column. On the right hand side also this is also one column. That is also 3 cross 1 matrix. So both are of same order and they are equal and their corresponding elements must be equal. Okay. So here given here is, this is x plus y plus z, right? And this is z plus x and this is your y plus z. So which is equal to, now it is 957. So now this is 957. Okay. So now these two matrices are equal. They are of same order and their corresponding elements must be equal. That means you can equate this first element is equal to first element. That is x plus y plus z is equal to 9. This is your equation 1. Again you can equate those second elements. Z plus x is equal to 5. This is second equation. And then you can equate those third elements. That means y plus z is equal to 7. This is your equation number 3. Is it clear to all of you? So now how can we get the values of x, y and z? So if you subtract 2 from 1, subtracting 2 from 1, what do we get? Subtracting 2 from 1, this and z and x will be cancelled, only y remains. You can get the value for y, isn't it? So therefore, let us write x plus y plus z is equal to 9. This is number 1 and z plus x is equal to 5. This is your number 2. Let us subtract it. minus, 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 right? So here z gets cancels, x's cancels, so y is equal to, that is 9 minus 5 is always 4. So we have got the value for y, that is y is equal to 4. Again, you subtract 3 from 1. You subtract 3 from 1, you will get the value of x, isn't it? So let's write here x plus y plus z is equal to 9, that is equation 1. And what is equation 3? It is y plus z is equal to 7, that is equation number 3. So let us subtract it again. So here you have to change the sign. So y gets cancelled, z gets cancelled. So therefore x is equal to what? That is 2. So we have got both values of x and y. X is equal to 2 and y is equal to 4. So how can you get the value for z? You have to put those values of x and y in equation 1 to get the value for z. Okay. So putting the values of x and y, putting the values of x and y in equation 1. In equation 1. Right. So let us write the equation 1 again. That is x plus y plus z equals 9. X plus y plus z equals 9. Let us put the value for x. What is the value for x? 2 plus, what is the value for y? It is 4 plus z is equal to 9. Right? X is equal to 2, y is equal to 4. So we put the values for x and y. X is equal to 2, y is equal to 4. Then z is z only, is equal to 9. So it is 6 plus z is equal to 9. Or what is the value for z is equal to 9 minus 6 is 3. Okay. So now let us write down the answers here. What are the answers? What are the answers here? X is equal to 2, y is equal to 4, and what is z is equal to 3. So these are the answers. That means x is equal to 2, y is equal to 4, and z is equal to 3. So these are the answers. So you can copy it. Now I'll give you the homework. Okay. These are your homework. That is from exercise 1, page number 133, from the same book, Higher Mathematics for Class 12 by S&A. So each question carries 2 marks, page number 133. So these are your homework. Question number 3 is, we did question number 3 here, right? So number 3, 1 and 2 are homework. You have to get the matrices A and B for which this A plus B is equal to this matrix and A minus B is equal to this matrix. This is just like a simultaneous equation. You can solve it as we have done in question number 3, right? So in this case also, find the matrices A and B for which number 2, A minus 2B is equal to this matrix and A minus 3B is this matrix. So you can solve these two matrices to get the values of A and B. These are just like your simultaneous equation. Okay? So you revise all the problems that we did today and you do this homework. Okay? So in the next class we will do more problems on matrices. Okay? So this much is for today.